All right, today we're going to talk about dimension changes in solids. We've actually already done this chart this year. We did this about 2 weeks ago, right before we did our project. Do y'all remember doing this at all? So if you turn to page 73 in your notes, you could have it out just to see it. But we talked about similarity ratio, perimeter ratio, and area ratio. Do y'all remember us doing a chart? SA or SR, PR, AR? Yes, no, a little bit? Okay, so let's remind. The general rule. Your similarity ratio is your scale factor. What are you multiplying by? That is one dimension. That's usually your sides. Your area ratio, how do we find the area ratio? Squared. We did A squared over B squared. Does anybody want to guess how to find the volume ratio? Cubed. A cubed over B cubed. Now, why is it cubed? Because it's 3 dimensions. Why is area squared? Because it's 2 dimensions. I need you to think about this. If you have something and you double, let's say my scale factor is doubling. Right underneath that, write times 2. If the sides are doubled, to find the area, don't you agree that means you double the length and you double the width? So how many times have you now doubled? Twice, which ends up being 2 squared. What is 2 squared? 4 times. So now your area is going to be 4 times as big. Well, what about volume? What if you double the length, the width, and the height? How many times have you doubled? How many different things have you doubled? 3 different things. So what is 2 times 2 times 2? What's 2 times 2 times 2? 8. So your volume will be 8 times as big. Does that make sense? Oh my gosh, my color coding is not good today. Okay? Are we okay with that? Now let's go up to the top. What is happening from here, this prism, to this prism here? The sides are times 3. Do y'all agree they're 3 times bigger? Yeah, all of the sides are 3 times bigger. Well, what's going to happen to my area of my base? How do you find the area of this base down here? Base times height, which would be, what's 1 times 2? 2 inches. And do y'all agree area of the base is big B? Right? What about the area of this base right here? What's the area of this base? 3 times 6, which is 18 inches squared. What's happening from here to here? Times what? Why is it times 9? So let's go back to this chart. This is for example 1. The similarity ratio, my scale factor, was times 3. My area ratio is times 3 squared, which is 9. Is that true? What do you think is going to happen to my volumes? Times 3 cubed, which is 3 times 3 is times 3, 27. Let's see if that's true. So go up a little bit. What's the formula for volume of a prism? Big BH. Do you agree we already found big B right here? So what is 2 times, what's the height? 3. What's 2 times 3? 6 inches cubed. And then same thing here. Big B is 18. What's my height here? Can somebody tell me 18 times 9? Thank you. Write that down, please. How do we go from 6 to 162? I don't know that by heart, so I'm just going to do that in Desmos. 162 divided by 6 is, oh, looky there. Did that work out exactly like I said it would? This works every time if your solids are similar, meaning your dimensions change all the same. So in this case, all of them were multiplied by 3, then this will work for the area and volume. What questions do I have? Open up your notes, please.
You said this would work as what?
As long as all the dimensions are changed, like all of them are multiplied by 3. Yep. All right? So, they're similar, exactly. Number 2, it says find the similarity ratio and the area ratio of 2 cubes with the volumes 729 and 1331. What am I going to do? Go backwards. What did I give you this time? So I'm going to write in my volumes. And I usually do second over first. It really doesn't matter which way you do this. But I'm going to do 1331 divided by 729. Write that down, please. 1331 divided by 729. And if I put that in my calculator, bless you, do I get any simplified number? No. So that doesn't really help me.
Well, you could do root 3, and then you could go from there to
I could do root 3. Why would I root 3?
because the number right next to it is root, or like centimeters 3. To take that away, you just do that.
Correct. Everybody look up. Do you agree? No, I'm at the board. Do you agree if I'm right here to go to the last column, I cubed it? So how would I go backwards? What's the opposite of cubing? Cube root. So right here, I'm going to cube root 1331 divided by 729. Everybody do that in Desmos. What is 1331 cube root? How do you do cube root? You can do CBRT, or you can go all the way to the bottom and put a little 3 there. 1331 divided by 729.
How do you do it?
CBRT,
CB?
RT, or you can go to the very bottom of functions. All right, do I want 1.2222 as your answer? No. Hit the fraction, what do we get? 11 over 9. Why is 11 over 9 my answer?
Because it's the ratio.
How did it come with 11 though?
Because it's the top.
What is 11 times 11 times 11?
1331.
1331. That's where it comes from. What is 9 times 9 times 9? 729. Okay. How do I find the area ratio now? Square 11 over 9. And you can square both of them. What is 11 squared? What is 9 squared? So this is 121 over 81 is my area ratio. Now these numbers are not the actual areas and volumes. These numbers are what you multiply the area and volumes by. What questions can I answer? We're good? If I multiply the area by 121 over 81, if I multiply an area, what's going to happen to my new area? It's going to be what? If I multiply, let's say I have an area of 10. I don't know, I make it up. And I multiply it by 121 over 81. My new area will be what compared to my old area? Why bigger? Because the numerator is a bigger number. Do y'all all agree with that? Okay. What if I flipped that and multiplied it by 81 over 121? It would be a smaller. So if the bigger number is on top, your area or volume is going to get bigger. If the smaller number is on top, it's going to get smaller. Does that make sense? Do y'all agree that's common sense a little bit? Yeah. All right, so let's look at the next question. If the volumes of the two similar solids, again we're dealing with volumes, are 512 and 13,824, what would be the scale factor to make the larger solid? So when I'm doing my chart, what did I give you again? The volumes. Which one am I going to go, which one's going to go up top if I want to find the larger solid? The bigger number. 13,824 over 512. It's asking for the scale factor. What is the scale factor? What am I asking for? The similarity ratio. The scale factor is the same thing as the similarity ratio. So, how do I find the similarity ratio? Cube root it. Now, did anybody put that in their calculator? What did it give you?
3.
No, this right here. Did anybody put this in your calculator?
24.
Not 24.
27.
So you could just put 13,824 divided by 512, and it's actually 27. You can simplify it, but you do not have to. You can either cube root 27. What's my answer? Or you can cube root that whole big mess. 13,824 divided by 512. It'll give you the same answer no matter which one you do. Does that make sense? Gabby, you still with me over there? Stay with me, please. So this is the cube root of 13,824 over 512. What did it give us? 3. So what is the scale factor used to make the larger solid? Times 3. That x just means times. That's what you're going to multiply it times 3. What would I need to multiply to make a smaller solid? Flip it. 1/3. Because do you agree you would flip this fraction to make the smaller solid? So you can just flip this. So you're going to want to pay attention to where the bigger number is and the smaller number is once I start telling you to make bigger and smaller solids. Okay? Any questions? We're good? Start this next question. This next question is a test question. How many of the smaller cubes will fit into this large cube? Anybody want to guess just right off the bat? Why 125? Huh? Just a random guess. Well, why? It has a 5 in it? Well, where does 125 come from? Yeah. Hey. How do you go from here to here? Do y'all agree that's times 5? What is that? That's my similarity ratio. Do y'all agree? If I'm fitting cubes inside, what am I dealing with? Volume. Area is outside. Inside is volume. How do I find the volume? 5 cubed is, and that's my answer.
Yo, miss, I might be Albert Einstein.
You literally looked at my computer.
Alright, that's one way to do this. That's not the only way. If I would have not taught you today's chart, would anybody have approached this another way? How? Would you have done the volume of the big cube divided by the volume of the small? To know how many of these fit into there? How do you find the volume of a cube? S squared. So 25, not squared, sorry, cubed. 25 cubed divided by 5 cubed. No, you can't do that. Is 15,625 over 125. And put that in the calculator, and what do you get? Or you could just straight up do, what is 25 cubed divided by 5 cubed? Either way, you get 125. So these are just two different ways to find this answer. You can either divide to see how many fit in, or you can just do your chart. Are we okay? Write that down. All right, last one we're going to do. Nope, it's not. We have a whole section, but that section's going to go quick. Last one that we're going to do the chart for. The surface areas of two similar figures are given. SA equals 248 inches squared, and SA equals 558 inches squared. The volume of the larger figure is given. Find the volume of the smaller figure. What am I going to do here? Make a chart. And what do I have to fill into this chart? Not SA. The surface area, I'm going to call it area ratio. SAR, I guess I get what you mean. My middle column, because it's surface area. It's area. Which one's going to go on top?
The smaller one.
Why the smaller one? Because I want the smaller number. So 248 divided by 558 is what? 248 divided by 558 is 4/9. Does everybody agree that's 4/9? How does that help me? How do I now go backwards to find my similarity ratio? Why square root and not cube root? That's area, not volume. So instead of cube rooting, I'm square rooting. And the square root of 4, square root of 9 is 2/3. Is that my answer? What do I now need to do? I'm trying to find the volume. So I need to find the volume ratio. How do I find the volume ratio? 2/3 cubed. And you can put that in Desmos or do that in your head. What is 2 cubed? What is 3 cubed? So 8/27 is my volume ratio. What am I going to do with that? To find the new volume, I'm going to do 8/27 times the volume of the bigger. Can you please put that in your calculator and tell me what you get? Louder? 240 inches cubed. And that's our answer. So if I'm giving you area, find the similarity, use that to find the volume ratio, and take your volume ratio and multiply it. Are we okay? Do I have any questions? This is one of those things that as I explain it, it's like, okay. Once y'all do it on the homework, it's going to go quick. Okay? All right, can I change this? Everybody wrote it down? All right, this next part is different. Why?
Because they're not similar.
They are not similar. Y'all see how it says non-similar up top? And because they're non-similar, do y'all agree up front, I told you we changed all 3 sides. All 3 dimensions were multiplied by 3. That's why we're in the 3rd dimension column. What if I only change the base, the length and the width? How many dimensions am I changing? If I only change 2 dimensions, then I'm going to stick in this column. What if I only change the height? How many dimensions is that? The height is just 1 dimension. I would just do what the 1 dimension column is. So if you have non-similar, meaning you don't change all of them, Instead of doing similarity, area, and volume, you're going to do 1 dimension, 2 dimension, 3 dimension. So, look up. The volume of a cylinder is 100 cubic feet. What do we know about the volume of a cylinder? It's base times height, but what is the base of a cylinder? No. Base, area. Pi r squared h. Do you agree with that? The height of a cylinder is how many dimensions? It's 1 dimension. Put 1D right there. Can y'all write that down just like I have it? The radius is 1 dimension, but for a cylinder, what is it? Why is it 2 dimensions? Do you see how the radius is squared? Because the radius is squared, that is 2 dimensions. Does that make sense? So, for this next question, it says, the radius is doubled, but the height remains unchanged. What is the volume of the new cylinder? Well, if my radius doubled means what? If my radius is times 2, that's not x squared, sorry, I wrote it weird. If my radius is times 2, how many dimensions is the radius? 2D. Do y'all see how I just made a triangle with 3 dots? That means therefore in math. You're going to see that a lot in Algebra 2 and Pre-Cal. Therefore, my radius is actually what? 2 squared times bigger. Well, what's 2 squared? So this is going to be 4 times bigger. Does everybody see where I got the 4 from? If I'm doubling it, the radius is squared. What's 2 squared? What if I was tripling it? 3 times bigger. What's 3 squared? Sorry, 3 squared times bigger. It would be 9 times bigger. Does that make sense? So if it's 4 times bigger, what is my new volume? The original volume was 100 times 4 is 400 feet cubed. Does that make sense? Write all of that down, please. I'm sorry? It didn't have a pi, nope. Okay, what if the height was doubled, but the radius remains unchanged? So this time, my height is doubled, times 2. And it's what? It's only 1 dimension, therefore, how many times bigger is it? It's just 2 times bigger. Well, if it's 2 times bigger, what's my new volume? What questions do I have? Last but not least, what if both the radius and the height are doubled? The radius, that's a height. The radius plus the height equals times 2. How many dimensions is that? That's all 3 dimensions. So because it's all 3 dimensions, what does that mean? 2 cubed times bigger. And what is 2 cubed? 8 times bigger. Because it's 3 dimensions, you're going to cube it. 2 times 2 times 2 is 8. And what is my new volume going to be? I'm going to have to throw this marker away. And that's my answer. You have 15 minutes. Kids that started working right away and didn't goof off finished last period in less than 15 minutes. Your homework, your last homework of the year, maybe. I think. I don't want to lie to you, so I'm not going to say it's 100%, but I'm like 89% sure. But your last homework of the year is due tomorrow when you walk in. You do not have to show work.
It's relieving so much stress.
Please refresh. It should be there now. Get started on it and go.
Is this the Cinco de Mayo game?
This is a